Alright, first attempt at recording the script. Recording with my dog. I'm just gonna go get my computer so I can read the scripts. So excuse any dog noises. He is quite the noisy boy. Hey, Belly. He's also very sad at the moment, so he needs a bit extra loving. Perfect. Let's get the script open. Here we go. If you've kept up with Tenshi's streams, you'd know that my username is the lesbian ant, and that's actually my username here too. Quick content warning: detailed descriptions, drawings, pictures, and videos of alive as well as dead insects, predominantly ants, will be shown. Welcome to a cozy Quora deep dive. I'm having really fun with this format, so I thought that in this video we could look at my favorite little guy, the lesbian ant, aka Mycocephalus smithii. So if you couldn't tell, the cozy part in Mycocephalus is my nickname. And since no one really wants to pronounce it Kose, like you would Mycocephalus, everyone just calls me Cozy, which I'm happy with since it's way cuter anyway. But let's get into it. Mycocephalus smithii, my spirit animal. I mean, just look at that little face. And just look at these articles. Ant gives up on sex completely. They live completely free from males and sex in general, tending to their mushroom gardens. Isn't that the dream? The cottagecore lesbian dream? Today, we'll be learning about this asexual lesbian fungus gardening ant that I so adore. Quick facts. So if you Google lesbian ant, Smithy comes up because they live in colonies of only queens, where they reproduce asexually through cloning. This makes them the only asexual fungus-growing ant in the world. They are also the most recently discovered of all asexual ants. They are self-sustainable, meaning that they tend to their own gardens, as well as being debris collectors, similar to leafcutter ants. This is very impressive, since farming ants usually have slaves or rely on some other type of manual labor from other ants, but they do it all themselves. They are predominantly found in Latin America and are of the Mycocephalus genus, obviously, which means that one of their close relatives are Absolutus, and just look at them. Oh my god! If they weren't males, they might be my favorite ant. They are definitely my second favorite ant as it stands right now, because god, those colors! I just wish there were more live pictures of them. Genus information. Myco ants are neotropical. No, not neurotypical. Though I wish I knew they were, since ants can display neurodiversities like leafcutter ants, and since they are very similar genetically, there's a possibility Mycocephalus ants might be neurodiverse as well. If you have any free time, you should really read about the Acromyrmex echinacea, because it's so cool. I love brains and psychology, especially in ants. Anyway, they're a neotropical genus of fungus-growing ants, tribe Atini. The genus is most commonly found in Mexico, south of Brazil, and Argentina. Like other Atinas, they mainly grow fungus from the leucocoprine tribe, which is just a type of mushroom. They look like this. This is therefore their main food source. They use many different substrates to grow their fungus, from dry leaves to fruit. Ravling and Bachi discovered a workerless incline species in 2010 that they gave the worst name, by the way, castrator. So castrator ants are parasites of goldii ants. So goldii ants are parasized by castrator ants. I hope that makes sense. The two diverged relatively recently, like 37,000 years ago. and evolved in the same geographic region, making the parasite-host pair an example of sympatric speciation. That's not terribly important to the Smithii ants, but they are cousins to a social parasite. You know, you kind of have to talk about it, especially since the cousins are being weird with each other. If that's not hot gossip, I don't know what is. Nests. While we're on the topic of Goldie, I feel like I need to mention this Oxford study comparing Goldie and Smithii ants' fungus farming techniques. It's, well, completely useless, and I love that someone poured so much time into just looking at ants. I could never do such a thing. Anywho, the study proved that Smithii ants' fungus gardening are slightly smaller, both in working force and in size. The study also showed that each garden has at least 3 queens present. The study aimed to learn how ant nests with fungus gardening are built by observing different stages of garden development. The research suggested that the process begins with the gyne. Gyne? Like designated egg-laying queen. Anyway, the gyne establishes the colony and the fungus garden. After a couple of generations has emerged, the workers take over various tasks, which they communicate to each other through something that looks like making out, which I think is really cute. These tasks include digging new nest chambers and cultivating fungus gardens by introducing mycelium pieces. Then fungus cultivation in these new chambers begin by introducing small pieces of the garden, attaching them to the chamber ceiling. The pieces of mycelium are fed with organic particles from leaf litter and grow mycelial strands hanging down from the top of the chamber. The final growth stage is reached when the fungus garden fills the entire chamber. Eggs are placed in the same chamber, but not covered with mycelium, as in other Athene species. They are later disposed in small cavities in the mycelium, where they develop into larvae and then pupae. The study highlights the impressive construction of these chambers. I mean, ants can farm. Isn't that incredible? Isn't that... They're like little people. That made my dog really happy. He's on my side. The construction and the chambers is so impressive since it manages to keep the fungus garden's brood dry, even in the presence of water, since, you know, Latin America, it rains a lot. But they still keep the entire nest dry despite the deep cavities. This design not only provides a stable environment for the brood, but also minimizes risk of flooding and microbial disease. That's incredible. Riveting, I know, but this also gives me a great segue to talk about the Smithii gardens, because, oh my god, they're incredible, and there aren't many flattering pictures. Well, there aren't really many pictures of fungus farms at all. But just imagine fungus farms hanging from the ceiling like chandeliers. The stark contrasting white against the dirt walls light up the chamber. The gardens have been described as curtains covering the walls, and next door you can see the farms arching across the chamber like a pearl necklace. The whole atmosphere is ethereal and almost otherworldly. But then you look at the pictures and you get this. There aren't good pictures at all. I mean, we have Alex's pictures, which I adore. I mean, look at these. I mean, aren't these the cutest little ladies you've ever seen? Especially when you compare them to the usual pictures of dead specimens, which they just look so sad and curled up. And anyway, back to look at Alex's pictures, but they're not very good at showing what the nest looks like itself. They are, however, great at showing how adorable my little girls are. I love them. And that's all I need. That's all I need. Anyway, now back to information about the genus. Identifying features. Myco ants are monomorphic, categorized by their numerous spines on most bodily surfaces, including a pair of occipital spines. And I'm gonna keep talking, but just look at this little guy. Look at this, it's such a goofy little drawing, I love him. Anyway, they usually have two to three pairs on the pronotum, which is kind of the shoulder area, 5 to 6 pairs on the mesonotum, which is like the upper back, and 2 pairs on the propodium, which is like the lower back, with the last pair being the most developed. On the dorsum of the petiole, the part that like connects the ass to the rest of the body, which has 2 spines. There's also a definite circlet or crown of spines on the prosonotum, which is a feature not found in any other genus in the world. Smithy specifically is one of the 2 species in which the workers lack prosomonal spines in the center of the crown. Generally, they're very low, sharp crests in the region. In most cases, they can be separated from the other species that lack these spines. The Brazilian obsoletus on the basis of distribution. Otherwise, they can be separated by lateral pronotal spines, which are long and sharp, unlike the obsoletus short and blunt spines. Specimens that have bumps in the center of the crown could be confused with TARDIS ants, but can usually be separated as the TARDIS ants had definite prosonatal spines. It can be separated from other 2 species, Curvus spinosus and Goldie, which also have these teeth based on several different characters. It differs from the Mexican and Central American Curvus spinosus, as the anterior pronotal spines are well developed, and the propodal spines are straight and direct somewhat vertically. It can be easily separated from the Brazilian and Argentinian Goldie on the basis of distribution, and that the inferior lateral pronotal tooth is properly developed in Goldie. The females have small lateral pronotal spines and tiny inferior lateral pronotal spines. The females are slightly larger than those of Curvus spinosus, which is about 3 millimeters in total length. Additionally, the propodal spines are bent slightly downwards. These characters would easily separate it from females. Now to the fun part, reproduction. Basics of ant sex. Now you're probably no stranger to ant reproduction if you've made it this far, but let me summarize it real short and sweet for you. The circle of life for ants begin with the queen laying eggs that develop into larvae, then pupae, and then they become workers. The most common form of reproduction is through sexual fertilization, which means that a queen, that is sometimes referred to as the gyne, reproduce while flying, along with one male. When the queen ant is fertilized, she lives on for 15 to 20 years depending on the species, creating her own colony with the eggs that were fertilized in that one mating season. The male is disposable and will lose his wings and then die shortly after mating. Once the queen has created her colony, a nest will be built and she will never mate again. Instead of repetitive mating, she stores the male sperm in a specialized pouch. During the mating, the queen and male have wings, and when they're done, they simply take them off. Here, I made a video explaining it when I was like 8 on my DS. I feel like I could do a better job at explaining this than 8-year-old me. So, in many species, the queen raises her first offspring to adulthood without eating. The vast majority of ants in a colony are workers, so they're infertile females. A few eggs develop into winged elates, either queens or males, which are haploid and hatch from unfertilized eggs. They are the ones who go on to mate with other ants, so the circle continues. A lot of scientists are really impressed with this form of reproduction, since it greatly increases reproductive rates without jeopardizing the queen's safety. Now, jumping into asexual and other forms of uncommon ways to reproduce. Hymenopteran insects, so like bees, ants, and so on, are characterized by a haplodiploid sex determination system, in which females are derived from fertilized diploid eggs, and males are derived from unfertilized haploid eggs via Arenidochus parthenogenesis. However, the production of diploid females from unfertilized eggs, known as Thalattocus parthenogenesis, is common amongst hymenopterans. The last decade, however, has seen an increasing number of known Thalattocus hymenopteran. All of a sudden everyone's non-binary. Youths don't even know what a female is. Especially in eosocial species. In studies taking advantage of this simplified model of reproduction, Thalattocus social insects have been acknowledged as a model system in behavioral ecology and sociogenomics. Family-specific. Formicity, so like ants in general. We can already find odd cases of reproduction here. For example, in Cataglyphus. They technically have nothing to do with my little lady smithy, but hey, it's a fun example with good pictures, so shush. Besides, it's kind of related. Just let me explain. So, in 2020, a study was made by Kun, who looked at how in some species, queens produce workers sexually, but produce new queens by fertilizing their own eggs. This is called conditional use of sex. Their colonies are made robust by variation amongst workers, while reproductive offspring receive only the queen's DNA, according to a study by Percy in 2004. So while they are not asexual species, they can still choose to produce asexually. This is similar to how parthenogenesis works. Another group within Cataglyphus reproduces through social hybridogenesis. They also use sex conditionally, but a species consists of two genetic lineages. The queens mate selectively with males of the opposite lineage to produce workers. This means that you can create genetic diversity without creating fertility, aka they're just glitching the system. So ants have a tendency to fuck around with the laws of reproduction. But the fuckery is not quite at the level of smithii, since they are still reproducing sexually. Subfamily specific. Myrmicinae. We can look at monomorial trivial to inch closer to my dear smithy. Trivial are parthenogenic ants whose virgin queens lay female worker ants. Here's a beautiful graph showing the virgin queens of different colonies. This then seems to be the norm, at least in Japan. But it's not just the females who go on to live their best lives as ace queens. There's also a rare occurrence of male parthenogenic ants, such as Oocyria brioi and Pristopermec punctatus, which we love our ace kings. But back to the ladies. Triviale queens retain undergenerated spermathecae, suggesting that they have a low level of specialization to male-free reproduction. However, there's no evidence of infection with Thalattocci-inducting bacteria in this species, meaning that there are no cases of microorganism-inducted Thalattocci in ants. Spiroplasma has been detected in various ant species, including another Thalattocci species, like our Lord and Savior smithii. In Solenopsis, aka fire ants, a genus closely related to Monomorium, spiroplasma has been detected as a dominant bacterial taxon in whole bodies of adult worker Geminata, thus drawing the parallels between the two. Spiroplasma is well known as a sex ratio distorter in Drosophila, and its role in the host's reproductive biology deserves further study in ants. So, like always, more research is needed. Thalattocus parthenogenesis is often considered a trait overrepresented among introduced or invasive ant species. The reproductive ants, although some studies have categorized Triviale as invasive, No exotic distribution has been recorded so far, and there is insufficient information to support the possibility of an introduced origin of the Japan population of the trevally. The known distribution range of the species is far from limited than those of successful invasive congeners, such as Pharaonis and Monomorium floricola. A preference for disturbed and urban habitat is shared widely among invasive ants. Ito listed trevally along with Stromogenus membranifera, Punctatus, and Brioi as Thalatakis ants found in quote-unquote open disturbed areas. Trevally nests were found even in a thicket dominated by deciduous broad-leaved trees, which is not typical for quote-unquote open disturbed areas. Additional studies of this species' social structure, such as queen numbers and model of colony foundation, will help to evaluate the potential invasion risk of these species as an ecological consequence of its life history. Tribe-specific, Atini. Typically, there's one queen per colony. Every year after the colony is about 3 years old, the queen lays eggs of female and male elates that will pass on the genes of the queen. Before leaving the nest, the queen stuffs some of the fungus's mycelia in her cibarium, which kind of makes me think of this image, you know the one. Oh boy. Anyway, the winged males and queens then take their nuptial flight to mate high in the air. In some areas, species flight synchronize with local colonies' virgin royalty flying at the same time on the same day. And I swear to God, when it's ant mating season where I live, every time I breathe in, I get ants in my mouth because these guys are everywhere. It's unpleasant trying to work. However, if you are looking to start your own colony, this is a great time to walk around with an open cup of some sort and catch yourself a fertile queen. Some species' queens mate with only one male, for example, Seriomyrmex and Trachymyrmex, while some are known to mate as many as 8 to 10 times, such as Atta sextans, which is a hilariously fitting name. Please, I'm trying to work. You're banned! After mating, all males die, but their sperm stay alive and usable for a long time in the spermatheca of their mate, meaning that many ants father offspring years after their death. So, tribe-specific mating is pretty generic. Now getting into the genus Mycoseparus. I'll briefly go over each species in the genus, since there's no real cohesive similarities within the genus, aside from, how goldii and castrators are related, but we'll get to them. Going in alphabetical order, starting with castrator, the best name. As we know, they are social parasites of goldii.
In a study, we can follow how castrators act in laboratory conditions.
Castrator males copulate with castrator females as soon as they come in contact. During this time of ongoing mating activities, females and males will run erratically, and males mount females seemingly at random. This lasts 10 to 30 seconds. Single males attempt to copulate more than once. The rate at which the queens lose their wings can be generalized to 1 queen per hour. And losing your wings means losing your virginity, basically. Postcopulatory females did not tolerate mating attempts of males and walked faster to outdistance their pursuers. So the inseminated queens will outrun any males trying to mate. The queens are done, They mate once, they're done. After copulation and the wing shedding, the recently mated queens gather and engage in allo-grooming frequently licking each other's meso and metasomas and wings for extensive periods of time. They have a little all-girl aftercare sesh. Males start dying 12 hours after the mating event. Curvus spinosus have no record, or maybe I'm just stupid because I can't read. So we'll just pretend they don't exist. The best description for their social life I could find was, this species apparently lives in nests of Smithii in Mexico. The workers are slow and timid, and forage together with those of Smithii, which is cute but common. So from what I understand from that very short text, Curvus and Smithy nest together and probably have a social relationship with each other. But regardless, we'll just move on to Goldie, as I like to call them, castrators' better half. As you know, polyicons, which according to the study I'm referring to, means that they are evolving into cheaters, which is just polyphobic, if I may. Anyway, polygyny in Goldii colonies means multiple reproductively active queens coexist. Facultative polygyny in Goldii, particularly observed in the Brazilian Amazon, may have contributed to the species' social parasitism. Particularly observed in the Brazilian Amazon, may have contributed to the species' social parasitism evolution, and miniaturization of sexual offspring may have promoted assortative mating and reproductive isolation. Unlike castrators, Goldii mate through nuptial flights, typically in September-October, so mark your calendars. These differences in mating behavior, coupled with morphological distinctions, indicate full reproductive isolation between the two species, highlighting the role of body size, genital morphology, and mating locality preferences in assortative mating. It doesn't really make sense for there to be host-parasite mating, since host and parasite male genitalia differ distinctively in that parasite males lack certain parts that are functionally important during copulation because they lock the aedegus into the female genitalia to stabilize the copula. Under laboratory conditions, host and parasite reproductives did not copulate. Besides, host and parasite reproductives of an extant population are unlikely to interbreed inside the same colony, because in the presence of a social parasite, only workers' brood were found in the parasized Goldii colonies. Host sexual offspring were absent, even though they were present in neighboring colonies, indicating that castrator queens suppressed the production of host sexual offspring. Anywho, this was supposed to be brief. So moving on to Absolutus. They reproduce similarly to Goldii through nuptial flight in early November, which lasts for 2-ish hours. The study that documented this behavior states that it's unclear whether the elates flew into surrounding vegetation and formed mating aggregations, as has been reported for Goldii, or if they mated in leaf litter. That's all we know about those guys. Moving on to Tardis. And again, maybe I'm just stupid and can't read, but the only information I could find about their reproduction is one article calling them sperm-filled, and I wouldn't want to elaborate on that even if I could.
All I can say about that is that they reproduce sexually.
So, finally, climax time! Smithy! Okay, so we know Smithy ants reproduce asexually. But as we've learned, this isn't anything new in the ant world. So what's up with Smithy specifically? Well, instead of having males, which they may or may not mate with to birth workers, Smithy have no males or workers. They're all queens, copies of each other. So let's get into the nitty-gritty of the asexual smut that we've all been waiting for. So, there are over 20 models describing the advantages of sex, since the short and long-term advantages of sexuality outweigh its twofold evolutionary cost, since they are all queens copies of each other. The near absence of asexual lineages that persists over long evolutionary time suggests that the disadvantages of asexuality generally outweigh its benefits. However, asexual organisms arise sporadically throughout the tree of life, and the study of obligate long-term asexual organisms may hold the answers to why almost all eukaryotes reproduce via meiosis and zygonymy. So really, there's just not enough research since the trait is very uncommon. Some research suggests independent lines of evidence indicating that smithy might be capable of Thelatochus reproduction instead of just cloning. Evidence for this is the absence of males, which led to the hypothesis that queens of smithii might reproduce via Thelatochi. There's also a comparative study that compared Goldie and smithy nests that we talked about earlier. So to remind you, the nests seem to be connected to each other, forming a colony network. The connected nest system suggested that colonies multiply by fission, potentially influenced by the reproductive biology of the species. Additionally, males were not encountered in smithy nests during the myco mating season in Peru, meaning that smithies have goldies over for dinner, but not after dark, you know? In Puerto Rico and Panama, even though symbiotic, sexually reproducing
Like a separate species.
engaged in nuptial flights, suggesting that smithii might be obligately asexual. I'll skip the nest details since I already went over those, but it's worth reminding you that chambers contain one gyne. No other ants were present in the chamber. Now the thing that makes them lesbian. While all desiccated queens' spermathecae were empty, meaning that they haven't mated with males, their ovaries were still well developed and contained several mature oocytes per individual. The base of each ovariole had multiple corpora lutea, indicating the reproductive activities of each female. Hence, all smithii queens showed signs of Thelatochus reproduction, but not with males. So, they, are having gay sex, which means they only engage in sexual activity for pleasure and not for any reproductive reasons. This behavior, however, was only visible in queens, since none of the 50 examined workers were reproductively active. Each worker had a pair of ovaries, with a single ovariole per ovary. Ovarioles did not contain mature oocytes, and yellow bodies were absent, meaning they become yellow bodies when they're not virgins anymore. So technically, only the queens are scientifically accurate homosexuals. Another important question is whether sexual reproduction was lost and secondarily re-evolved, or whether sexual reproduction represents the ancestral state in smithy. The only real answer we have is that the population inferred as a sister group to the sexually reproducing populations, which was confirmed to reproduce colonially. However, a likelihood ratio test of the constrained and unconstrained smithy topologies did not detect a significant difference between the two topologies, so we don't know for sure yet. There is a lot of detailed information about their DNA, but unfortunately my dyslexic ass looks at this and goes, no, just no. So if you want to look at it and get into and sex science yourself, be my guest, but my little brain cannot comprehend what this means. However, I will say that I am very thankful that DNA records exist, because maybe sometime in the future I will stop being dyslexic or something. Anyway, looking at the deets, Calderat smithy queens have been found with sperm. Shocking, I know, but let's not get in over our heads. Males are yet to be detected. Sexuality is a spectrum after all, and hey, who says females can't produce sperm? But I mean, since queens have been found to be sexually active, maybe some queens in some specific areas just are more bi-leaning. So, to sum up everything we've learned, Smithy seems so far to be the only representative of type A asexual ant species, where queens produce queens and workers via either cloning or teletachy, and workers are sterile. Males were suggested to be absent, however, the finding of inseminated queens might suggest otherwise, but without any further evidence, I think we can just pretend that never happened. The population genetic data from field colonies and laboratory breeding experiments find no evidence of genetic recombination in asexual Smithii populations, indicating apomixis as the genetic mechanism of asexual reproduction. The only other species where apomixis has been suggested is the little fire ant Wasmannia orapunctata. Similarly, Acapunctata also uses genetic recombination occasionally. This means that regardless of the need for sex, ants will engage in mating rituals, which is why Mycocephalus smithii is an asexual lesbian ant species that deserve all your love and attention. Wasn't that fun? Now you know where my username comes from. The longest explanation ever, but it's worth it, right? You get to learn so much, and it's very useful information too. Okay, before I go, I have to talk about this song really quick. It warms my heart. I am stupid, unfortunately. I don't even know what language the song is in, so I don't know what the lyrics mean. Probably could figure it out, but I'm stupid and lazy. But regardless, I love the song. I listen to it like once a week, maybe. That's an exaggeration, I don't know. But I listen to it a lot. It warms my little heart, my ant-loving heart. I hope that if you can take anything away from this video, just remember that 1, you're normal, and 2, the world is full of interesting creatures that display all kinds of different attributes and characteristics, and we know so little about the world, and we need so many more researchers. So if you have an interest, if you have the motivation, just go outside and stare wherever. I guarantee you that you will see something that is undiscovered or under-researched. If you want to make your mark in the world, if you want to find something to give your life purpose, do research about whatever your heart desires. I guarantee you someone out there will absolutely love and adore your findings. Thank you for watching. I hope you'll have a wonderful day, night, or evening whenever you're watching. And always remember that you are loved. Bye-bye!